So I did this exact same workshop on Wednesday and kind of really like delved into all the settings, how to get going, um, all how all this stuff works, and it's kind of boring. So I figured I'll skip that and kind of just get right into the nitty gritty, and then try to work in some of this necessary info as we go, and then and maybe end it with some of the other really technical stuff. So the one thing I want to mention is in our Grasshopper components are kind of color coded. So you can kind of just keep that in mind when we're working. Like the green ones are for queries, uh, the blue ones are parameters or items, uh, deconstruct, modify. When you're adding stuff to Revit, they're the blue ones. So kind of as I'm going through here, creating stuff in Revit, uh, just kind of be aware that these different colors mean something, and hopefully that'll help you out a little bit. So what I'm going to first show is I have some Rhino geometry, which is just closed polylines on various layers. And then I have some Rhino blocks. So if I pull up my block manager, these are all named the same as the uh, Revit trees, and you'll see why. So, and the same thing here, where I have layers for grass. These are going to be the same, correspond with the same names here. So we could easily tie our Rhino geometry into our Revit uh, when we're making our lists and stuff like that. So one of the big plugins that I use a lot is called Elefront. This plugin allows us to get information from Rhino, uh, such as layers, geometry from the layers. Uh, it works well with blocks, as well as assigning or getting user text, which is equivalent to a parameter in Revit. So highly reliant on that in these definitions. The reason all these have a 6 on them is that Elefront, this is Legacy Elefront, which is 4.0. Elefront has a beta 5.0, and they don't want to get their buttons confused. So they made this really obvious 6, so you know which ones are which. So we're going to be working in the Legacy Elefront. And the way this situated is that we can reference, we can filter things, has various attribute tools, annotations, which we're not going to be using, some block tools, baking tools, and then some tree data manipulation. So to start off, we're going to reference by layer, since we have things on layers. And I can put in a value list that will, anything with these brackets will auto fill out with our list of layers. So the first one I'm going to get is the planting layer, which is going to pull up these 19 different blocks. I can use deconstruct block from the Elefront right here. You'll see when I'm working in Grasshopper, I'll typically use shortcuts for various things. So we're also going to query our types. So this is getting a Rhino.Inside component. So the first thing I'm going to do is deconstruct these blocks, which will provide a name. That gets all the names of these blocks in the file. I'm going to flatten this list and then search for my types in the Revit. So there we go. Since they had the same name, it's going to find all the Revit types here. Then when we deconstruct a block, it also provides a plane. So we're going to use that. So we're going to add these, use an add component by location right here. I'll pull that up in our Revit dialog. So that's in the families, add component by location. So it's asking for, actually, let me get you display the full names. There we go. So it's looking for location and type. We're going to go ahead and put our type in here, and our location is going to be the plane. We have matching lists. There we go. And I'm going to be constantly moving around the screen since I'm working in a much smaller screen environment. But as you can see, it's placed a tree from each of those types into Revit. Since this is actually getting our layer information, we could set this to automatically update, or we can manually update. For now, I'm just going to manually update. But you can see as soon as we make a change to that layer, update, it's going to modify our Revit document to add in the trees. So these trees are all they're coming in all in the one direction. So kind of fun one we can do. Let's pop it up into our 3D view. So these are all in the same direction. And when we're planting tree, I mean, you don't want, typically you're not going to want that same uniform look everywhere. So we can also modify that here because we're using our plane as location. So we can rotate our plane by an angle. So what I'm going to do is get the size of our list. So there's 23 trees at the moment, and we're going to make a range. So our angle, if you hover over things, it's going to give you information. You can see it rotates in a counterclockwise around the z-axis in radians. So we can give it a radian. We can just use our range 0 to 1, or since it's radians, we can go 0 to 2, but this will be fine. And so we're going to make that use our count to get the number of rotations. And as you can see, it has one for 0 and one for 1. So we're going to have to remove one of these steps right here. So we can use an expression x minus 1. So now we have the same amount, 23, going in here. I'm going to graft that. So we have 23 lists matching in with our 23 planes, rotation. And we also want to kind of randomize that. There's a bunch of shuffle, randomize components depending on what plugins you have. So I'm just using this one. Provided a seed of 5 here. So now that's going to mix up our list, kind of make it nice and random, and we'll pump that into our location. So now you can see everything has a slightly different rotation. And since we set this up in Grasshopper to count the list, if we add in additional trees right here, it's going to rotate everything again. So that's just the planting some trees. Another workflow I want to show that often is used in landscape architecture is usually if you want to make a really nice, pretty 2D site, you're going to be using filled regions in Revit. So here I have closed polylines that are on the various layers that match our filled region types in Revit. So once again, we're going to use our reference by layer. This time I'm going to just type in regions with 2 semicolons, because what this is going to allow, so these are all a sublayer. So now this is going to get any layer, any sublayer underneath the regions. There we go. 8 polylines. And I want to know which layer that is. So Rhino attributes here. How about get Rhino attributes? So this is going to give me the layers. I'm going to create a set. So we have individual ones, and then I'm going to filter these out. I'll show you exactly why here in a minute. There we go. And then we're going to do the same thing we did up here by querying our type. And we can put on our set list here. And we should have a list of filled regions that we can now use our add region component. It's found under our annotations. So this doesn't have an icon yet. This is a recently added component. You could see it over here in our reference area in our Rhino.Inside guide that when we add in new components, the release notes, once we have our icon, it'll show up. So we don't even have those on here yet. So these are very new, but this is where you check to see what's been updating, how frequently we update, bug fixes, new components, all that. So I'm going to give it a boundary. It's also, since it's a 2D item, it's looking to be in a 2D view to be placed, and it needs to know the view. So I can get my active view from Revit. It's over here in the View tab. And it's looking for a type. There they are. And I'll try to fit this in. So once again, if I set this right here to automatically update, I change my surface here, my polyline, going to change in the Revit. If you have this on the same layer, what's that? That'd be grass. It's going to put a hole in it. So what that does is in our geometry, say now that first branch has two polylines on it, and we're going to want to be aware of that, because all those, it's going to try to make it one big region. So if we had a bunch of stuff on a single layer, and we wanted them separate, to do separate ones, we'd have to graph that. So we'd have, so these are being, its location's being controlled from Rhino, so we had to move it over here. Any object that's getting put into Revit from Rhino is going to be pinned because of our element tracking. So if you right click on one of our add components, any of the blue components, you'll see that there's a tracking mode of update, replace, and disable, as well as some error modes. The essential thing you need to know on the update is that if we add in a okay, here's a really good example of a contextual crash. So what happens sometimes on it's a soft crash. We're on any of on the Rhino.Inside.Revit, it's 3 programming working at one time. So you have your Revit, your Rhino, your Grasshopper, and Revit being a database opens up a transaction for everything you do, and occasionally it gets confused and loses context of which program is going on. It's a soft crash because you could save all your work, you could save your Revit, but you could see over here that I have a lot of things kind of grayed out, and it's lost context. So at that point, you gotta save everything and then restart your Revit. In anticipation of that, I keep an extra Revit going just for this. And since I'm starting a new one, just in case it happens again, I'm going to go ahead and open up a fresh instance. And we're going to move on to our second example. So the first example showed us how to get filled regions, or get our Rhino material, Rhino elements, filter them by layer, query the types in Revit, and then place those and control those from Rhino into Revit. The filled regions and placing component families. So on this one, so another thing to mention is, you notice when I opened up Revit, Rhino is already ready to go. This setting is available here in the options, where I can have Rhino, start Rhino on startup. I can also isolate settings if I want a particular template to open up, because the Revit units, if you're in metric or in feet, you want to have the corresponding units opening up in your Rhino as your Revit. This is also where you can set how it checks for updates on the startup. I'm in the daily build, which is going to be a little bit more have the latest bug fixes, the latest components, but it also on any given day could have a broken component because it's being worked on. But sometimes it's updated several times in a day. That's where you're going to get your latest and greatest. The release candidate is a weekly release, approximately, that has the latest components a little more refined, latest bug fixes, and then your public release, which is like a monthly, our stable build. So you could set up which ones you want to get updates for. Recommend a release candidate because that's going to give you the latest and greatest without the latest and greatest problems. All right, so now I'm going to go more into some of the topography tools, generating our topo surfaces, placing some components on the topo surface, as well as our regions. Once again, we're going to use Elephant. See if I can get this tiled a little better. See things. All right, so in our Rhino, I've got various layers once again. Got a mesh, got points that I generated off the contour lines. So we'll start with that. So I'm going to use reference by layer and a value list. Go here. Start off with our. Actually,
Is there an advantage to using the Elephant reference by layer tool as opposed to the geometry pipeline component?
Yeah, it has a little more. The geometry pipeline. Yeah, you can have the layer by name and several geometries, but for instance, it's not going to reference blocks, which reference by layer here is going to do blocks as well, and you're not going to have this as this control of auto updating, as well as the visibility and only referenced objects. So when it says referenced objects, you can use a work session where you're linking in an additional file. So if I do a work session and I attach a topo file that I don't really want in my document, but I want to reference in Grasshopper, I can do that through this reference by layer component, and the only visible objects is pretty good. So it has mesh type filter, B-rep filter, curve filter, and point filter, name, and layer, and that's pretty much all you're gonna get. You got a couple more. The only time I use a pipeline is if I'm doing a small example for somebody and I don't want to have them have to download a plugin. I'll use the pipeline to reference the layer. But like I said, I'm a huge fan of the Elephant because once you have objects in here that you can filter by all these various attributes.
Mm-hmm.
So if I had a particular attribute, a key value pair that I wanted to filter, so I only wanted ones that were like had a certain elevation assigned or had the letter zone A or something like that, you can reference and then filter things. So it gets really, really powerful. But all right, where was I? I'm going to show we have a couple components at topography by mesh. So we have a site category over here, project elevation, location. You can query site locations, and here's our blue ones, which are add building pad, add topography by mesh, by points, and then add topography regions. So pretty limited. We're going to be adding some more, particularly in like adding points to topography is a huge one. A couple more, but can't think of it at the second.
Are there plans for developing tools that would add topography as like a more of a NURB surface within Revit? Get a more
Um,
sinuous, naturalistic looking topography surface.
yeah, I mean, I think that would be more of a function of like a direct shape or a massing category. If
Mm-hmm.
you're, because we're pretty much working with what Revit has available, right?
Right.
So if you're looking to have the features of a topo surface, you're pretty much limited to points or mesh.
Mm-hmm.
So adding a mesh, pretty straightforward. Right here, we can edit our mesh in over here, and that will translate here. But you'll notice one of the features of Revit, uh, if you do it by mesh, you can't edit the surface. So that kind of takes away a lot of the functionality. But you could put holes and meshes and stuff like that, where if you're doing add topography by points, you're limited to either exterior points or interior points. So you can't really make a hole by assigning, like if I had you can't have exterior points on the interior of your topography. I don't know if that makes sense. I can show an example of that later though. So right now this is a tracked element. So if I delete this, it's going to throw a warning saying, hey, you're deleting a element. So if I go here, it says, hey, this element is no longer tracked. Boom, but it leaves the element and unpins it so I can delete it. So now we're going to go ahead and add our topography by points. Now this is a lot more flexible. So I don't know how familiar you are with Grasshopper, but we don't need the previews. So don't draw any preview, wireframe, or just selected items, which is really nice if I want to see what in a large definition what a particular component is referencing or doing. You can use this preview geometry for selected objects only. But I'm going to turn off our mesh. So now that these points are in here, we have a topography that could be edited. So I could change a point location manually, whereas if we were doing the mesh, you don't have that ability. And that's a function of Revit. So I'm going to reference by layer again. Layer. And so we can do a few things here. Suppose we can add a pad first. Just go through all the different existing components. Back in our topo site, add a building pad. Once again, I'm going to turn on our display so you can see the full name. So it's looking for a boundary, type, or a level. It really only needs a boundary. So it's looking for a planar curve. It's going to add that pad for our topo surface. The other component that we are using is add region. So I'm going to get our reference by layer. And we'll go for grass. So in this example, I've already set up a few materials as well. So we're going to not only, so it's looking for topography. So we're going to feed our topography into here. Then we have our grass boundaries. Oh, there you go. So it adds in your region per our closed polylines over here. But as you can see, it comes in with the default site category material. So if we want to know, we go in here, you can see in the properties it has the parameter material, which is by category, which you could set. We can do that in Rhino.Inside.Revit as well. Quickest way to figure out what's available as far as information is use the inspect component, which doesn't do a whole lot, but if I hit shift and then double click, it's going to expand to all available parameters and stuff like that. So the area, the surface area, but the one we want is material, which is currently none. So now if I hit control and double click on this component, it gets rid of the ones that aren't connected. Now we can query materials. And I know that the same, I will just do a value picker here. I know I named them site something. There it is, site grass. So that's a filterable list of all our materials. And then to change the element parameter, we use the element parameter component. The element is going to be the region. In this case, it's a subregion. The parameter is going to be this material parameter. And then the value is going to be that right there. So now we have grass in a topography, but we also want to do the same thing with our roads. So I'm going to go here, add a road, add topography region. That's going to be our boundary. If I double click on a wire, I get a little grabbable thing there. So that added our road. And we can do the same thing over here. Element parameter. I can use the same list, but instead just click the road. So element, parameter, and our road material. It looks like we're missing a boundary. So if I click here, so right there, there's a grass. So it looks like I have road and grass on top of each other. So if I just copy object to layer, then refresh my road, there we go. So a few more things. Let's add in some of these trees. Also have some other features we can add in. So to do that, I'm going to go ahead and I'm going to get a list of the blocks in our document. So there's our list of trees, but this time I'm going to reference by block name using the elephant, and I only want visible objects. There we go. That gives me a list with a lot of zero values. So we can clean that up using a clean tree right here, where we remove the empty branches. And now we're going to have a nice two lists with the various blocks in them. It's keeping this numbering that it generated from this original list, so I'm going to renumber right here. And once again, we'll deconstruct block, which gives our name. So we're going to create a set, all the names. So we only have two of them, the Hawthorne and the Lombardy poplar. So now that we can do the same thing we did on the previous example, is query our Revit types. That should give us matching lists of Revit components. So now we can add component by location. So we have our 6 planes here, which you can see it's a branched list. So we're going to need to trim the tree, which is a really common Grasshopper practice. So that now we have 2 branches, 0 and 1, that match our types, 0 and 1, and we can add in our location. So we'll go ahead and add this location, add by type. All right, so you're going to see that our trees are buried. In Revit, the option is to be able to, you could select your trees every time and then pick a host and select your topography. That feature is not available in the Revit API, so we'll have to get a little bit more creative if we want to keep the everything kind of, I guess, parametric. So to do that, we're going to filter. So we want to get our meshes from our Revit. So we're going to need our topography. So I can query a category. We're going to create a Revit filter. And we're going to search for topography. There we go. Go to category filter. Query elements. This filter, and that should return all of our topography. So what happened when we split our topography, it created, it keeps the original surface, but then it has our subregions. So if we try to get our element geometry here, you're going to see it the first list has no geometry. The second list has a couple meshes, and then a bunch of curves, some meshes. So we only want the meshes. So we're going to filter by type. Here's the elephant component. Then a value list here. So we're filtering by meshes. Once again, we're going to need to clean our list. So I can just borrow this one. If I tap Alt, that's going to copy it. Now we have our meshes for the complete, for all of our topography. I'm going to go ahead and flatten that and do a mesh join. Give us one big topography mesh. Then we can do a mesh closest point. Got our mesh, and the point we're going to use is our plane geometry here. So now that is projecting our points to this mesh. So it's going to land our all the trees we placed onto the surface.
The mesh closest point wouldn't necessarily only go in the z-axis, though, right?
Absolutely. You could do this a couple different ways. I mean, if you're trying to be real particular, you could shoot a point up from like.
Like a mesh ray intersect.
Yep. So I could use this right here in the z direction, right? Shoot a line up and then intersect with that mesh.
Mm-hmm.
If I wanted to get really, really particular. But yeah, you're correct. If it was a little, depending on your site, that could, that's definitely something to be aware of. But now that we've set this up like this, if we edit our mesh or change our topography in some sort of way, the chances I can select objects, and I'll lock those. I'm going to move these up just a little bit. Refresh. So that changed our topography, but it also moved these up.
Mm-hmm.
And that's a workflow to get stuff placed on your topography that Revit can't host. This next one I'm going to show is we're going to use the railing family. So let's unlock. So I've got these lines around the edges here on our curb layer. So I'm going to reference by layer. Curves. There we go. And I need to query types. We're going to add a railing. And so I'm going to set this category to railing here. and that's going to give all the types of railings in the project. I'm going to use that value picker. Of this one called Curb and Splash. That's going to be our type. And with a little luck, we place some rails. So once again, these are all, if I go into a wireframe, see we made a 3D curb that goes around, but it's not following our, oops, I didn't have any curb lines there. And they're backwards. So I'm going to need to select objects and there we go. So now we got these curbs, but they're not up on our topography. So you could either manually go like that and then pick the host. I think it's that one. Nope, I picked the wrong one. Grab this guy. Oops. There we go. I don't think that did it. Anyways, we got I've got a Python component that can do this for us. So I'm going to open document. I think it was this one. Oh, that was a mistake. There we go. So I've got a simple Python component that will let me set the hosts to all this. So I'm going to grab our elements of the railings, and then I need the particular subregion of the roads. All right, and there we go. So that set these curbs all on onto these 3D roads. And now that those are part of the topography, when the terrain changes, those curbs will follow along with it. Let's see. I think I'm gonna. Do you have any questions about this?
No, no, that process makes sense.
All right. Now I'm going to take it out and a little bit into left field. I'm going to open up first of all, start a new Grasshopper document because that will, whatever I was doing there would add into a new document. I'm going to open up a different one. This is one an example I did for somebody that asked the question on the forum of how to add points to a floor. So using a floor element to kind of fake road work as well. And I'm opening this one because I've already got the families going. And I'm not going to go through the whole process of just doing this by scratch. So I'm going to open up the document. All right, so I'll walk through this real quick. Pretty much what we were just doing. Referencing these layers, which are Rhino layers with closed polylines. Referencing them in Elephant. Same thing. In the there's an additional definition I'm not going to go into, but called step one, which actually creates all these floors from our information. I won't go into that. Then what these do is I get all the points and I create um, points along the curve, like every 7 feet in this case. I get all the corner points, I merge them, and then I have a mesh in here as well, right here, and I do what we just, I projected the point. So that's another way to get those. So I projected the point and the Z value to the mesh. And then I also moved them up in the Z value to where these points are. So to get to the good part, I'm going to activate this, which is going to create our floors. So these are all various floor families that represent the curb, the sidewalk, this little berm and water area. And then this Python script, which I hope we can get into a component as well, is going to add points. So it's going to pretty much do that add point to floor. Let's go ahead and do it. So now we have a 3D floor, which if I turn on floors, the interior edges, you can see these are all meshed out, but it's a way to fake topography that some people like to do.
So it seems like a lot of times if you have like a planting area on top of a building, the topography components don't work. You do have to try and use like hack it with floors. So it seems like this would be kind of that
Yep,
application if you have,
it is a popular workflow. There was somebody here on a Wednesday session that was, that said this was an important workflow for them. So here's a good example. Since this is a Python component, it doesn't have our element tracking. So if we were to change something in our spacing, for instance, of our points, it would just continually add more points. So on this definition, what I recommend, so say we wanted to make a lower resolution or a higher resolution, I would switch this to the tracking mode of replace. So now when I run it, it's going to go back to its flat floors. And then over here, so if we were going to change the spacing to like a real low resolution for some reason, this was a huge, actually that's the opposite direction. So we wanted it 10 feet apart because maybe we were looking from really far away and we didn't need to see much. Now we can add this in as a different resolution, and I'll put it back onto update, recreate, and you'll see our floors are going to be less faceted. So it's a good way to kind of control the resolution of those objects. And you could do the same thing in our previous definition where I was making the where I had contour lines and I was kind of dividing those to create our points for the topography. You could do the same thing. So you could have a rough topography every 20 feet and then dial it down where you need it. So, but when you're playing around with this definition, you want to replace it. make any changes, turn it back to the update, and then hit the button.